man presenting it. Welcome to the session. I don't know what number it is, but it is What's New in Hybrid Cloud. Make sure you fill out your session evaluations and all that fun stuff. I'm Jeff Bisty.
And I'm Paul Talcott.
All right, just like rehearsed. Awesome. So we're going to be talking about what's new in hybrid cloud. And what's fun about this presentation is I've done this for like 6 shares in a row now. And it's always just what's new and what's exciting that I've kind of come across that I think that is being like a motivating factor in the hybrid cloud space. The things that we're going to cover are serverless cloud computing, cognitive computing services, and microservices. Microservices has been around for a while, but we're going to kind of drill down on it a little bit more, talk about how it's being used, what's on the horizon, and Paul has something pretty exciting to talk about there as well. The reason I get to change this up every single time I present is because the cycles for what changes in cloud, they're so extremely short. I did a presentation at Share maybe like last year, and I was talking about, oh, there's this new thing, there's this whole new thing, there's this great new thing people are doing. And someone in the back of the room said, that's fantastic. Somebody would want to use them, but what if 10 years down the line somebody wants to do something else? You're going to have to change everything again. I said, 10 years? 10 years? We'll be talking about something different next year. And things tend to kind of follow this hype curve, you know, when new technology comes in. There's this great new thing that everyone's talking about, and you see this new website or this new mobile app that seems to be doing something magic. And you find out what's actually powering the technology behind it, and you find out, oh, it's because this new subsystem is available, or this new application, this new framework that everyone's using. And you start hearing about it more and more. It catches buzz. And then as it gets more buzz, people start adding more features. And now it supports this additional library. Now it's whatever compliant. It starts getting bigger and bigger. Maybe IBM finds out about it, and we start glomming onto it. It gets bigger, and it becomes more mainstream. Then either the thing gets too big, or the use cases change. People decide, you know what, the market isn't driving the way it was before. The requirements aren't what they were before. Everything shifts. And all of a sudden, it feels like there's this gigantic, momentous effort that no longer matches what people want to use it for. And we've seen this before with web servers, with app servers, with analytics tools, even in the mobile space. And invariably, there's a rebirth. Either somebody says, you know what, we're going to take this because it's an open source project. We're going to fork it and do something brand new with it, maybe take it down to its core or add some new features. Or just make something completely else and try to disrupt it, or replace it, or be the next phase. And invariably that catches on, and then someone says, hey, you know, that's a pretty cool idea. It's a really cool framework. What if we add a little bit more to it? And this whole cycle continues again. So you really can't latch onto something and say, I'm going to ride this out for the rest of my career. It doesn't really happen anymore, especially in the cloud space. It's a constant struggle to stay on the cutting edge. And I saw this before. When I first got into doing IT, we worked on the LAMP stack. And say, give me an instance of Linux, Apache, MySQL, and PHP, and I can accomplish anything. Just give me those 4 things, right? I'm going to spend the time to set up my system. I'm going to have Linux, it's my operating system, Apache, it's my web server, MySQL, or Postgres, or something like that, to store my data, and then some sort of processor, you know, PHP, Perl, Python, some sort of language in order to script that all together and push it out into the web server. I can accomplish anything. In the last couple of years, you've seen a push towards something called the mean stack. And the mean stack is slightly different. We have MongoDB, or any sort of object store type database, a key value store database, Express, Angular, and Node.js. Starting from the bottom up, we have Node.js, which is a server-side JavaScript, basically. And then we have Angular and Express, which provide Angular provides kind of a front-end interface framework for it to display these nice user interfaces that are kind of standard. And Express, which is a very easy framework to create web services. I can say, here's my endpoint, here's the port it's going to listen on, here's how I'm going to handle errors, all that kind of stuff. So I don't have to reinvent the wheel every time I make a web service in Node.js. And this is the common stack. Except what's missing from this stack that was in the previous one, in the LAMP stack? There's no operating system there, right? So it's a small tweak, and we don't expect somebody to run this on something that's not an operating system. It's just that the operating system is kind of irrelevant. I don't care if I'm running in a Linux, Windows, Mac, ZOS, whatever. As long as you give me these 4 components, I can capture the world. I can do whatever I want. And of course, I'm not going to always use MongoDB. I'm going to use whatever sort of framework I want, whatever sort of NoSQL database I want there. So I was talking about the mean stack and how great the mean stack is, and one of Paul's friends said, well, dude, why are you still talking about Angular? Everyone's using React.js now. And I don't think we're going to start calling it the Meegan stack or the Mearn stack, but it just goes to show that, the stack is still the same. It's still providing the same functionality. We're still going to keep calling it the mean stack. And we'll say, well, it's something Angular-like. But this React came in. React.js, I believe it's forked off of like some of Facebook's earlier efforts. But it's something you start seeing a lot more web design now. Say, okay, well, this is based on React, so I know it has a little bit more shelf life. I'm probably going to use that. So one of the, that just kind of sets the stage for the idea that we have to keep on top of what people are using, because those are the libraries we want to put out there. That's the support we want to be able to provide. One of the newer things that's really starting to take off, but still has a lot of runway to change, is this idea of a serverless computing. Has anybody heard of either Amazon Lambda or OpenWhisk? All right, good. The idea behind this is if we take the typical cloud model, so we have platform as a service, infrastructure as a service, platform as a service, software as a service, right? We start out with the infrastructure as a service. All that gives us is we get to put our servers somewhere else. Someone else is handling them. So I get to request X number of servers. Someone's going to handle all the wiring, all the cabling, all the racking, all the hardware stuff for me. Great. Someone's going to handle all the infrastructure for me. We move up to a platform as a service type model, where someone says, if the next step for you is to install a bunch of software so that now you can run your application on it, and there's nothing unique about the way you configure it, why not let somebody else do that for you? We call that platform as a service. I'm going to give you a WebSphere platform or a database platform, right? Platform as a service. And then lastly, we have the software as a service. Look, I don't care what software you're using. I don't care what kind of middleware you're using. I don't care about the operating system. I just want to consume a service, right? And in the idea of like Twilio. Twilio is a company you can use to send and receive text messages and phone calls and do all sorts of communications just by making REST calls. I don't care what platform they're running on. They happen to be Intel. They happen to probably use some sort of Amazon thing. It doesn't matter to me. I'm only consuming their services. Well, those are kind of the 3 pillars of cloud there, the 3 models. What if I have a little bit of code, like some Node.js code or some Java code, and I just want to run it? I'm going to bring my own code. I don't want to use somebody else's service. At the same time, I don't feel like supporting a platform to run it. I don't want to consume another server. I don't want to have to keep it up to date. I just have code. Just code. I don't want it to run somewhere. And that's what these serverless computing models attempt to solve. Amazon has something that's called Lambda. IBM has something called OpenWhisk. Google has something, which name eludes me at the moment. But the idea is just add code and just consume services and let the infrastructure handle it itself. And the cool thing about serverless computing is I'm only going to pay for what I consume. If I call this service 500 times a day, I'm calling for 500 executions of this code. And here's kind of the model I see this fitting into. It's almost like its own separate fork of these stacks over here. It almost falls in the bottom. And we're saying FAAS, function as a service. I have a very succinct function that I need to be called, and it's very stateless. So the thing to keep in mind with all this, it is very, very, very new. There's no killer app for it yet, which means that the killer app is yet to come, or that we'll see this kind of fall by the wayside. Still, it's something very important, I think, to keep an eye on, because people are still using it. And they're starting to find various use cases for it. Like I said, you're going to pay for what you use. It's stateless and short-lived. And when I first started playing around with cloud technologies, like Amazon and Bluemix, what I found it missing was the idea of there's no shell script I can run on the cloud, right? If I'm running a server and I have it under my desk or I have it off somewhere else, I can always log into it and run a shell script. I might need it to run it to gather some diagnostic data or to clean something up or just to get something ready to build a report. And that was kind of missing in the cloud space. In the serverless model, I can actually take my Node.js code, upload it, and I can say, here's the REST endpoint I want for it. When I issue a GET, I want you to run this code. Or when this fails, I want you to run this code. When someone checks something into GitHub, run this code. When a failure happens in Git, do this. And it's not just my code. Obviously, I have JavaScript, Swift, and Java. But on the Bluemix platform, I can plug into these other modules that are located within it. So I can do Watson translation. So when a message comes in on my Slack channel and it happens to be in French, and I want to know what it says, I can set up a bot, basically, in OpenWhisk that's going to translate it. It'll detect the language, translate it, and put it back into the channel. That's incredibly helpful. I can use Cloudant to store data. I can use weather to pull the weather data. I can send things out to mobile devices. And like I was talking about, Slack and GitHub are also supported right out of the box in OpenWhisk. So I found it very interesting because I can actually take my code, upload my Java Node.js code, and say, take the output of this and shove it into this other module, which can be one of these. It's by far the fastest route to getting something running on the cloud that I've found. So as far as a playground to play around with, it's something pretty interesting. Hi. So yeah, I know what you're saying, Jeff, that's great and all, but we're at Share. Why would I want to use that? Like I said, I want my Slack team to be notified whenever a build fails. When someone checks in bad code, I can chain that together as an action. That's not something that's going to run all the time. It's something that's action-based. And that's the thing about this serverless computing is that they're action-based. Something has to kick them off. They're not going to run persistently. Otherwise, I'd be paying out the nose. The idea is to kick these off quickly, have them run, and have them end. I want to create a web service to automate room availability. So when someone checks availability, it can run a series of code, get the answer, send it back out, and shut down again. I want to create a chat bot for my product to supplement the current knowledge base. I want people to be able to come in and search for an answer and then put the answer back out to them. Again, something that doesn't have to run consistently. It just needs to be available to be brought up. Or I want to get a notification every time that there's a disruption in the force, right? Event-driven type stuff. All right, on to cognitive. I said cognitive, it's in big letters, so I get like 20 points for this, right? That's how that works? When you say a word so many times, it kind of stops having any meaning? It's kind of felt that way lately. Everything is cognitive. Everything is analytic. Everything is cloud, right? If everything is cognitive, then nothing's cognitive. Well, to me, cognitive is a very specific subset of artificial intelligence. Artificial intelligence is any time that a computing program attempts to mimic a human, very simply. It can just be a script that is going to look at your output and perform a basic function and say, oh, hi, I see you're looking for this. Let me perform this action for you. Cognitive is, let me go back here. Cognitive, for me, falls in between basic AI and machine learning and deep learning. We'll talk about that a little bit more. But I want to talk about this robot that we got. My manager was down at World of Watson last year, and he saw these Pepper robots. Has anybody seen these robots before? He thought they were awesome. He saw them walking around, talking, doing all sorts of crazy stuff. And great, we need a bunch of these robots because we can do some fantastic things. I saw them talking about blockchain and hybrid cloud. Imagine if we had all these robots, all the cool stuff we could do. So we ordered a bunch of these robots. And we were all excited because who doesn't love playing with robots? And took them out of the box, powered them up, and the thing just sat there blinking at us. Every once in a while, it would say, I'm bored. I said, me too, buddy. So we bought this robot, and we quickly found out that it doesn't do anything by itself. You really have to program it. And there were some people on my team who were really upset. They said, this robot doesn't do anything. You have to program it. And I'm saying, this robot doesn't do anything yet. We get to program it. The cognitive thing says we get to fill it with whatever personality we want to. So the first step there was really managing expectations, and that cognitive is not a brain in a box, right? It's not a real boy. It all comes down to code. It's not magic. It's not plug and play. There is some programming there. It's not science fiction. It all is code that has to be written and is getting executed. It's all ones and zeros. And it's not a replacement for people and talent, because any sort of code, cognitive or not, that's going to run on it is going to be written by a person. Like I said, cognitive is a step between AI, basic AI, human faking, and machine learning and deep learning. Machine learning and deep learning, well, machine learning is when there's a feedback loop involved. This is based on how things work. I'm going to change how I react in the future. I'm going to train my model. And deep learning says, I'm not just going to train my model, but I'm going to teach myself how to learn things. And that's for somebody with like PhDs and lots of years to figure out. I'm stuck on this cognitive thing. I think this is pretty cool. It's exhibiting signs of perception. So when you say, wow, I didn't think it could figure that out on its own. It's a good mesh for services. It is a hotly contested area. I think one of the biggest selling items this past Christmas, was the Amazon Alexa thing. Seemed like everybody got one. And I know everyone got one because they were saying, Jeff, I got one of these Amazon Alexa things. What do I do with it? Why did you buy it? I don't know. Looked kind of cool. When you think about Siri, when you think about cars you can talk to, Alexa, Microsoft Cortana, again, Google has one that I can't remember the name for right now. This is a hotly contested area. Everyone is trying to become the hub that you talk to, the focal point for how you're going to interact with your electronics. And I don't see it as something that's going away anytime soon. You might have recently learned that H&R Block is teaming up with IBM to bring Watson to their tax services. So when you go to H&R Block to do your taxes, Watson will be sitting there, in a computer, saying, well, if you gave it this value here and this value here, you should also check this value, either because you might be getting audited or because there's the potential to get some more money back there. And H&R Block is using this as a key differentiator for them from their competition. But going back to the whole it's not magic, it's not a real boy thing, some quotes from the article I found. It's not magic. You have to teach Watson over time. It's not going to surprise you because everything it can do is something you've taught it to do. However, it provides a more engaging and interactive experience. And it's a crawl, walk, run learning experience. The pace of Watson, once it's trained, is faster than much more than other humans. So what does it mean to be cognitive? These are some of the services that are out on Bluemix you can start using now. I've been playing with these, and when I first came into IT and first started learning programming, there was a very solid line. Things you can do with a computer and things you can't do with a computer. You can fake it, but you tire yourself out trying to do it all. So something called trade-off analysis, where if you state the goals and you state the metrics, you can then feed it input and say, which categories does this fall into better? Very interesting there. Visual recognition, I can send it a picture and get back, usually fairly accurately, what am I looking at? So with the Pepper robot that we have in our lab, I'm starting to send this service pictures from the robot's eye so it knows if it's looking at a football or a desk or a hallway or an open door. And once I have that in my system programmatically, there's a whole lot more I can tackle, right? An Alchemy API. This kind of is a catch-all. It's starting to become more specialized, but I can send Alchemy API a whole bunch of text and get a breakdown of what I'm looking at. What are the subjects in this piece of text? Is it positive or negative? Is it an editorial piece or is it fact-based? Again, if I can feed this something from the real world that hasn't been prepared for AI or for computers, now it's in a form that I can tackle programmatically. That leads itself to a whole lot more stuff I can do. Yes. That's a good, the question was, is the Alchemy API something that's pre-programmed, or is it something that I have to program? It has pre-programmed modules in it, but you can improve its intelligence by adding additional corpuses of data to it. So what I want to do really quickly here, which I think will be interesting, is I'm going to show you how you can get started with the Watson Conversation Services. I was shocked at how simple it was to do this and how quickly you get a result back. So I'm logged into my Bluemix right here, which you can't see on the screen. Close that. Hope this works. Wait for the projector to kick in. There we go. Excellent. Is that coming through in the back of the room? OK. Well, it'll have to do for now. We'll spend 5 minutes here. All right. I'm getting the go-ahead sign. So I'm logged into Bluemix. I have a bunch of services. You can see there's a lot of Watson services here. I'm going to go into my conversation service. Looks like I right-clicked it. OK. And there's a couple things I can hear. I can get my credentials to extend it out to other APIs. I'm just going to click on Launch Tool. And what I have here is I have a bunch of workspaces. And a workspace is, like Bill was saying, kind of a corpus of data. It's an individual self-contained training of a Watson conversation. So the one I built right here is called Grocery Store. I was going to do one based around a bartender, but somebody told me I shouldn't do that if I ever want to show it at an IBM conference. So what we have here is we have a conversation bot built around what somebody might be doing in a grocery store. And this isn't anything groundbreaking. You're not going to say, oh my God, what this guy did was amazing. What I want to show is how simple it is and how easy it is to get this set up. We have this idea of intents, entities, and dialogue. And an intent is an overall action that a person, or in this case our AI, is going to be performing. The first thing I could think of that somebody was going to be doing in a grocery store is help me find something. Locally, our local Stop and Shop just got turned into a Tops, and they changed where everything is in the store. Something else, people drop things. Jars of pickles fall all over the place, and somebody has to clean them up. And as a tall person, I'm always asked by shorter people, can you reach that thing on the top shelf? It would be nice if somebody else could handle that instead. So I have 3 basic actions that somebody could possibly be performing, something could be asked to do. So I'm going to start out with my intents. And this, you can start to see how some of the magic peeks out in here. Let's start with locate. So the goal is to help somebody locate something. And if you think about how many ways somebody could be asked to help locate something, it's limitless. What Watson asks us to do is give a couple of examples of how somebody would ask somebody to find something. And this is kind of a fun activity. I need some pizza. Do you have candy? Can you help me find macaroni? What aisle is the cereal in? And you can see I'm just kind of giving some examples. I don't have to say every possible permutation of could you help me find the pizza, soda, chips, whatever. I'm just giving some examples. Now, what Watson is doing here is saying, OK, I'm finding some similarities. I'm finding the action words. And I'm also, at the same time, figuring out what are kind of the objects we're trying to find here. So the more examples I give, the more fine-tuned it's going to be, the quicker it's going to be able to pick up on these things. It's also kind of a fun list to come up with, if I can be honest. And then we have entities. And entities are the things that we're talking about. So what I have here is I have a list of entities for the aisle number 1 items, aisle number 2 items, front desk items, produce aisle items, and help. And if we go into any one of these, so in aisle 2, we have frozen vegetables, ice cream, popsicles, just things that are in aisle 2. And I also have a number of synonyms for them. Somebody might come in and say, hey, where's the Tombstone pizza? Where's the DiGiorno? Where's the pizza? We want these all to mean the same thing. But these all fall under the aisle 2 items entities. And to chain this all together, we go over to the dialog panel. And this works exactly the way it looks. We're going to start out from the left and branch out to the right, conditionally as we hit things. So if something comes in, then the trigger is that it's a locate intent, we're then going to proceed over to here and start working down the list over to front desk. So now if the intent is to locate something and the entity is a front desk item, we're going to say one of these two responses. And I can set this either to sequential or random, so you don't get tired of hearing the same thing again and again. Same with IL1 items. If it's not an IL1 item, it's going to check and see if it's an IL2 item. Let me just get a couple of these just so I can remember them. We've got celery, straws, lottery tickets. And now to try to drive this, I can click on the little dealie over here and say, try it out. I'm going to say, where are the granola bars? If I were granola bars, I'd be hiding in aisle 4. And you'll notice I didn't have to explicitly spell out where are the granola bars in my list of intents over here. It knows clues that this is a location-based thing. It also picked up on the entity of granola bars, and it mapped that all together to give that output. If I ask it the same thing, again, help me find the granola bars. Aisle 4 is where you can locate them. Again, I phrased it slightly differently. If I say, whoops, I spilled a bunch of stuff over here. Hopefully it's smart enough. I'll have someone sent over right away. That's pretty cool, right?
So you didn't have to be specific about the intents.
Right.
It looked like you didn't have to be exhaustive with the entities.
Yes. It won't pick up on, it can't guess on an entity because an entity is, it's kind of, it has to be specific. And they're going to be a lot more precise. But yeah, the intents can be fairly widespread. One of the problems I ran into when trying to do the bartender version of this was that some things come in pints, some things comes in bottles, some things come in cans. So when I say, can you get me a bottle of this, it got thrown off by can at the front as an entity. So the order of how you structure the dialogue plays into this a lot. I thought that was pretty cool. And how this fits into the cloud space, really, let's go back to my slides here, is that this whole Watson thing is, it's consumable as a service. If I go up to that thing where it said connections and I get my authentication tokens, I can consume this from any sort of program I'm writing where I can consume a REST API. So I can take input from something and take the input from the user, send it back as well as an action to maybe page something, to send out a text message to somebody else working the store that says, somebody just dropped a jar of pickles in aisle 4. So it really plays into all this. And when we think about, all the companies that we work with IBM, they're all saying, well, how can I differentiate myself from another company that does almost the exact same thing? If I can put a user interface like that to my product, that's a big deal. Think about how you navigate mobile apps. Maybe not the Share app, but any other mobile app, right? If you're unfamiliar with the web page or the app and you want to find something, what's the first thing you look for? The search bar. You expect it to be up top, you expect it to be universal, and you expect to be able to find whatever you type in. And if I can present an interface like that that's going to land someone to exactly where they need to be, that's a huge benefit. People don't navigate anymore. They search or just know. We're doing on time. All right. Lastly, I want to talk about microservices. And microservices is really nothing new here. We've been talking about this for a while. And even the key idea of taking a monolithic application and breaking it down into these smaller services has also been around for forever. Doing it as APIs and doing it as services that someone can make as part of their application is kind of what's new. And we kind of think about, the Lego castle's great. But what if we think about this in terms of it's a bunch of pieces that we can take apart and build other things from, right? So what it actually is a microservice, typically part of a smaller suite of small services. It's not like one just appears by itself. It tends to be a set of 4, 10, 12, 25, whatever, that appear under the whatever category. Each one is running as its own process, And when I say process, I don't mean machine process. I mean it's a fully encapsulated project. Mask the complexity of everything behind it. And Paul's going to talk about this a little bit too. And it's built around business capabilities. I love this quote because when we talk about the success we've had with certain customers, we talk with another customer and say, we want to do the exact same thing. We say, that's great. That worked fantastic for them. Might not work for you. Any organization that designs a system will inevitably produce a design whose structure is a copy of the organization's communication structure. And note the date on that, 1968. The tools that a company creates, that any group of people creates, is going to closely mimic the way those people work. More so than the business logic. It's going to mimic the way those people work. With that, Paul's going to talk about something he's been doing in some skunkworks projects, so take it away, Paul.
Cool, thank you, Jeff.
Yeah.
So when I first joined the company, I was actually fortunate enough to work on a small little rebel team that was really leading the initiative on creating these services or APIs for ZOS. So we were really thinking about, what are the great features of ZOS and what are some of the, aspects of it that we can expose and really build services around that would be beneficial that other platforms can consume. So, one of the things that first came to mind was, the platform is extremely secure. So how can we take this aspect and expose it as, a set of APIs or a service? So what we ended up doing was we actually came up with a core set of cryptographic APIs like encrypting, decrypting, signing, verifying. And we create these set of APIs and tried to abstract away as much of the complexities and specifics of ZOS, but still leverage all of the great features that make ZOS so secure. So this was kind of like the lowest level. We built the APIs up. But now what's really great about this is that we can take these APIs and now we can actually go up a step higher and build a service around these APIs. And that's kind of the idea behind this product. And it's kind of a new idea, a new prototype that we're trying to get some feedback on, and it's called Enterprise PGP. So I don't know if anyone in the audience is familiar with PGP, but it's basically a really well-known encryption product. It's been open source, it runs on a lot of platforms, and it's been really well known for a long time. So, we thought, okay, so now we have, the really nice secure features of ZOS, and we have this open source, well-known product. How can we blend these two together? So what we ended up doing is we ended up building this kind of concept of Enterprise PGP, where you have this open kind of well-known security product, and it's going to leverage the security features of ZOS over RESTful APIs. So what you can do is you can actually start to take your single kind of single servers that all need to have their own licenses for their security applications and are all potentially a security threat, and you can kind of shift it to a single centralized point, which is extremely secure, and you already have your mainframe system set up. So we kind of went through this little scenario of, someone starting up a new business. They initially start out with just a small set of servers to run their operations, and slowly it starts scaling up and up and up. And as you start scaling up, you have more potential entry points for threat. You have more keys that you need to manage, and it becomes a nightmare. And your security administrator just put in his two-week notice because he just can't deal with it anymore. So wouldn't it be nice if we can kind of consolidate all this threat and risk and kind of, like I said, move it to a single centralized secure location? And I think that's what we have on the next slide. Right, so here you can kind of see each individual client can now offload any of the security operations to a single centralized point. So now you have your security bastion of your mainframe, and all of it is managed in a single centralized point. So you're leveraging the security capabilities of RACF. So you have all the access control managed on ZOS. You actually are leveraging the cryptographic hardware. So all of your keys are secure and encrypted under the hardware. So what's really nice about this is, like I said, instead of having each one of these be a potential threat or audit point, you now just have a single centralized point. But you still have the great open capabilities of PGP.
What I thought was kind of interesting, the way that you have this set up, is it's not just taking everything and pushing it off to the mainframe, because that wouldn't be very efficient either. There's still some operations that happen on the platform or on the device.
Yeah, absolutely. So what's really nice about this, so we're actually going to go a little bit more in depth into this idea in a session on Thursday called Skunkworks. I forget the exact title, but
if you search on Skunkworks, it should show up.
Yeah, it's supposed to be a really hot topic. So
Yeah.
if you've got no other sessions, you should definitely go check it out.
I've heard good things.
But what's really cool about this is, like I said, if you're familiar with cryptography, I didn't want to get too much in depth with it, but it leverages the concepts of public key cryptography. And with that, you kind of break up the operations using two sets of a key. You have a public key and a private key. So the public key is actually used to do the encryption. That piece of the key is not actually secure. It can be known to the public. So that type of operation, the encryption operations, can happen locally on the devices. But anytime that you actually need to perform an operation that requires the private key, which is the actual secure key, that gets offloaded to the mainframe. And that actually gets offloaded through this set of REST APIs. So anytime you actually need to decrypt the data or maybe create a signature, it's offloaded through the REST APIs to the mainframe, and like I said, it's all secured. It all goes through the SAF authorizations, through the cryptographic hardware if you have that set up. So it's still extremely efficient. You can still configure it where the client device can do most of the operations and then only offloads the secure operations to the mainframe when it needs to.
Next.
I think that's it. Right, so kind of just reiterating that same point, you have the great security features of the mainframe while still having, the nice, open, well-known features and capabilities of PGP that, a lot of platforms and products are already built on.
Cool.
Thanks, Jeff.
I'm going to skip that. There's Paul's slides. All right. I've been asked to talk about this. Any non-IBMers in the room? All right, never mind. Some things to know about. I guess I'll phrase this differently. We have a team, in addition to Paul's team, that are working on microservices. We want to put these out there either as part of the operating system or make it an offering somehow. Key value data store, similar to a MongoDB, something like that. Logging as a service, certificate management, and data compression. These are all things that has to happen regardless of what platform they're on. And in a lot of cases, this kind of stuff runs best on a mainframe type environment. These are some efforts that are underway. These are some of the bigger ones. And if you have a client who might be interested in them, come see me or talk to them about them. We're looking for sponsor users for this. If there's something that might be interesting, and we can say this is a customer that actually absolutely wants to do this, it'll give us a little more direction. We can take feedback and shape things based on that. Meh. Oh yes, Gabby. Okay, the question was where would we see those services running? And I think the answer is really wherever it is going to make the most sense. I know that's not an answer. If a company has a full-fledged cloud solution, we obviously want to be able to integrate it into there. If they're using Amazon, if they're using Bluemix, we want them to be able to be consumable as tiles in there. If they're using a developer portal, something like MuleSoft or API Connect, we want to be able to put them out there. As long as they're APIs, they should be serviceable on whatever platform. But they will be actually, the ones and zeros will be flowing through on a Z somewhere.
Okay. And one reason I asked the question is because on the logging as a service, now some of our monitoring tools are beginning to offer a SaaS
Yes.
licensing option. So I don't know if logging as a service is meant to be complementary to that or if it's meant to be something different.
Right, so the question is where does the logging service fit in? Because there are a number of our products that are starting to offer something like that. We see it as playing into kind of like an ELK stack, Elasticsearch, Logstash, and Kibana. It's kind of becoming a well-established stack of tools where I'm going to ingest everything, I'm going to index everything, and give it a searchable front end for it. We see it as feeding into that type of model. So not trying to solve everything, but becoming an ingestion and collection point.
You're talking about it in the context of being like a syslog even on a single system.
Yeah.
Cloud-based version of that.
Right, and whether it's, we can call it a cloud-based, I think ultimately it's going to be a service running on Z that is accessible from somewhere else. Not trying to push all the data off platform or anything like that, but keeping it centrally located, or keeping it so that services can tap into it.
Yeah, I was gonna say, that would be.
Yeah.
Have services being able to tap into it, because that just kind of goes to the whole automation of the
Right.
services process and making end users more productive. That's fantastic.
Yeah, absolutely. And I think as everything goes forward in cloud space, we're going to start hearing less about cloud because it's just expected. It's just like you don't say, I'm going to buy a cordless phone or I'm going to buy a color television. Everything needs to be enabled to work with everything else. And it needs to be service enabled. It needs to have APIs. The one-stop shopping isn't very appealing to anybody, I don't think. So how does this all fit together here? Well, I think we have our systems of engagement, whether it's a fancy robot or an iPhone. We're going to be interacting with applications that are running in a cloud, be it on-prem or off-prem. Doesn't really matter to me. But we're going to have these languages running out there. We might even be using something like OpenWhisk for serverless computing. Because of that, we can also have the connection back out here being driven and consumed by something like Slack for messaging. Anybody on a team that uses Slack? All right, back of the room, good. We might also want to leverage third-party services like Watson or something from the weather company to consume data. Twilio, something completely off-prem, something on another completely different cloud to send and receive text messages. And ultimately, the APIs consuming from the mainframe, which are running all the business application, the business logic, the stuff that really can't leave that safe bastion, where all the business logic lives. So this is how I see it all fitting in the grand ecosystem of things. And API Connect. Forgot there was another one there. Yes, Steve?
So do you envision that a lot of those microservices are leveraged through ZOS Connect on the mainframe and invoking their batch services to be able to link API to a running program on ZOS?
Yeah, the question was, do we see ZOS Connect as being the link between the ZOS applications and batch and cloud consumers? Is that about it? And the answer is yes. That is from an IBM perspective, that's the strategic direction going forward. And I see that as the direction that's making more sense than people rolling their own. I don't want to see that. I want to see everything fitting one model because it's easier to manage one endpoint, the ZOS Connect endpoint, and keeping that up to date and keeping that secure and setting the policy on there than it is to say, well, we have this thing running into here and that's at a lower level of maintenance. It requires this special care. Everything going through ZOS Connect, and I'm going to steal a line from Frank. I come from the lab, so that means two things. One, as far as I know, everything's free. And two, everything now pales in comparison to the next version that's coming out, and that's all I can really say about ZOS Connect. And then we want to surface all those APIs, whether they be Z, Open, Power, an array of graphing calculators, whatever, through API Connect, to make our developer portal. When we think about what we can do when we're using cognitive, when we're using hybrid cloud, we talk about hybrid cloud and we talk about Watson. And Watson that was a cute trick I showed you. It's kind of a neat conversation thing. We need to think about what workloads we're going to be driving, what things we have to be able to handle. It's not just find me where the spaghetti is. Think about the gate agent at an airline, and people come up to them and ask the same 3 questions all day. They ask them the same 3 questions 8,000 different ways. It's typically, is there an upgrade? How much more late is my flight going to be? And can I get on this flight? That's a query. If we think about what Delta flights can I book that will get me home by 4 p.m., is a fairly complicated query. That depends on weather, it depends on flights, it depends on your customer information. And if I take this in from Watson, there's no amount of line drawing that I can do in that tool that I showed you to get that answer. That data is going to have to come from a back-end Z system, something that holds all the data, something that can actually drive insight. What's different about my son's health insurance this year? That's a huge question that's going to have to dive through a whole bunch of data and process. Not something that can be answered by Siri, right? How do I make an outbound REST call from Python? I swear, the first company that builds documentation that can be interfaced from a cognitive interface is going to make a killing. Why is DB2 so slow right now? If I can tap into my back-end system diagnostics from a cognitive interface, again, huge time saver. Or can I take a group of 8 people that serves vegan food? Now we're tying into public cloud offerings too, because I'm going to make calls to OpenTable and Grubhub and find maybe the best place that serves vegan, that has group seating, that has availability for 8 tonight. So these are all questions we should be thinking about, things that we would love to be able to ask our systems of engagement, that we kind of have to say, okay, I'm going to get this piece of information, write it down somewhere, get this piece of information, write it down somewhere, and then figure it out myself. If I have an interface like that, that's a huge differentiator. And that's all I have. Do we have any questions? Or laughter. That's cool too. All right. Fill out your session evaluations and enjoy the food.
Because we're shit.